My research seeks to quantify the response of glaciers, water resources, and hazards to climate change in order to inform adaptation and mitigation efforts across a range of scales. So for example, at the local scale, we work with local communities to develop risk mitigation strategies in order to reduce hazards associated with glacier outburst floods. And at the global scale, we work to improve estimates of glaciers' contributions to sea level rise in order to inform policy and decision-making, planning, and management efforts. And the way that we do this is we use computational models that are informed by remote sensing and grounded in field data. One of the major advances in recent years has been the amount of satellite images that we now have access to that are really enabling us to measure and monitor changes in the Earth at an unprecedented level of detail. And this is really enabling us to utilize new data sets that are revolutionizing the way that we can calibrate and validate our models, and also incorporate different physical processes into our models as well. Some of my research focuses on a special type of glaciers called debris-covered glaciers, and if that layer of debris is thick enough, more than a few centimeters, then it will actually insulate the underlying ice and reduce melting. But if it's very thin, then that layer of debris is darker than the ice, and so it absorbs the sunlight more and can actually cause there to be more melting, and thereby cause enhanced melting. And so with satellite images, we're now able to estimate the debris thickness and therefore be able to account for that process in future projections of glacier changes. So what our research group is trying to do is really utilize these satellite images along with high-performance computing in order to push the envelope of how well we can project glacier mass changes and the impacts associated with those changes as well. We're currently working on two NASA projects. One is the NASA Sea Level Change Team, which is focused on improving projections of sea level rise, and the other is the NASA High Mountain Asia Team, which is more focused on water resources and natural hazards. And so through both of these projects in the next few years, we're going to be producing a lot of new data sets and improve glacier projections. And the ultimate goal of our work is to inform assessment reports like the Intergovernmental Panel on Climate Change, or the IPCC assessment report, such that our projections can have an impact on policy. And one thing that's really important to note is that as a society, we've shown that we have a remarkable ability to adapt to future and changing conditions. However, the question is, do we want to continue to adapt and respond to impacts in the future, or do we want to be more proactive? And I'm hoping that the work that we are doing is able to inform those future climate change scenarios and help policymakers make well-informed decisions about mitigation efforts in the future. Policy typically works on different scales, so we're able to produce these projections relatively quickly, but in order to have this information support decision-making, it really needs to go through the vetting process of assessment reports, and it takes a lot of time. Our climate is changing, and we have the ability to look at different climate change scenarios and understand what might be coming in the future. So regardless of whether you live in the high mountains or if you live along the coast, the way that glaciers change in the future is likely going to have a significant impact on your life. We need to start utilizing these projections in order to support decision-making and policy moving forward.